Hello and welcome to class. In this video we'll be studying about the frustum of a cone. Now before we look at that, it begs the question, what is a frustum? Now frustum is like any shape, or is a shape obtained by cutting off the upper portion of a pyramid or of a cone. It is a shape that is obtained by cutting off the upper portion of a pyramid or a cone. Now what am I talking about? Let's look at this diagram. Okay, so we see this diagram here. What does it look like? Of course, you see that it looks like a bucket. Okay, it looks like a bucket. So let me try to replicate that. So your cone is something like this. Normally this is how your cone should look like. Okay, this is how your cone should look like. But if anything should happen and then cause a portion of it to be cut off, let me try to cut off from this portion here. Let me cut off this. Hold on. Okay, let me try to. Okay, so we are having, remember that initially what we had there was like a cone. Okay, we had a cone, but a portion of it was cut off, which is what gave us this that we have here. Alright, so that's what we call a frustum. When you have a shape, either a cone or a pyramid, and then a portion of it is cut off, giving you that shape that looks like a bucket. A bucket is a frustum anyway, because you can, when you complete the bottom parts of it, you get a cone. So this is what we call a frustum. Alright, and in this video we want to first of all look at how to evaluate the volume of a frustum. Alright, so let me go ahead and clean up what we have here. So this is what we call a frustum. Okay, let me go ahead and now, how can we evaluate the volume of this given frustum? How can we evaluate this frustum under consideration, the volume of it? Now remember that the volume of a cone is given by the formula 1/3 pi r squared h, because this is the volume of a cone. Remember our V, we have looked at this in previous videos. So the volume of a given cone is given by 1/3 pi r squared h. Alright, but that is for a cone that is complete. But in this particular case, we are having a cone that a portion of it has been cut off and want to evaluate the volume of the remaining part, which in this case is a frustum. How are we to do that? Well, there is really no simple formula. There is no formula per se that we can just write and plug in the values in order for us to solve this. We can make use of derived formulas, but there is no express formula which we can plug in the values and solve that. So what we want to do is to make use of reasoning. We want to reason this out and see how we can be able to calculate the volume of a frustum. Alright, now let me go ahead and make another drawing. Alright, or let me use this one that we already have here. Okay, so if we want to find the volume of this particular frustum, the first thing that you want to do is to complete the frustum to give you a cone. So if I should eventually complete this diagram, I am having a cone. All right, so let me also go ahead and identify this. So I'm having a complete cone. All right, now what is going on here? What is going on here? You can agree with me that in this particular diagram we are having two cones inside. All right, so we are having the bigger cone, which would mean all this. When you take, okay, let me use another color for that. So we're having the bigger cone, which would mean all of these. Okay, this is the big cone. Now we're having this big cone here. All right, and then we are having a small cone. Can I use another color? A small cone is this one here. We're having a small cone. So if I want to bring out this diagram, look at what we are having. Okay, so we are having the bigger cone now. We're having this big cone, and inside of the big cone we are having the smaller one, okay, which was superimposed for us to get this diagram. All right, so if we want to find the volume of this frustum, logic dictates that what we have to do is to find the volume of the bigger cone, which we can call V1, minus, we'll find the volume of the smaller cone, so this is V1 and this is V2. So when we find the volume of the bigger cone minus the volume of the smaller cone, then what is left is simply the volume of the frustum. Okay, you might want to watch this over and over again for you to understand this particular statement, that for us to find the volume of the given frustum, what we need to do is to find the volume of the bigger cone minus volume of the smaller cone, and when we do that, we are going to be left with the volume of the frustum. All right, so let's go ahead and look at an example and see how that is workable. Let me clean up now. Okay, so let's say that we have a frustum. Let's consider this diagram that I have here. Let's say we have this diagram. This is the diagram, is a cone. Is a cone, and we have a frustum as part of that cone. All right, just like that bucket shape. That's a frustum. So we have this shape. Don't mind the drawing. You know, it's quite a tedious task trying to make all this work. So I have this. Okay, I think this is better. All right, so I have here now. Remember that this is the cone. This particular portion from here to here is the frustum. All right, this part, the down portion of it, that is the frustum. So let's try to like label this diagram. So we are having a diagram like this, given that the height of the cone is 16 cm. Let's say that the height of this cone is 16 cm. All right, and we have the height of the smaller cone. Let me draw that by this side. So the height of the smaller cone is 8 cm. Is 8 cm. Okay, now of course the radius of the bigger cone, that when you consider this bottom part of it, the radius, let's call the radius to be 8 cm as well, and for the smaller portion, let's call the radius there to be 4 cm. Now we are expected to find the volume of the frustum. we are expected to find the volume of the frustum. Just like we explained moments ago, that in order for us to calculate the volume of the frustum, what we have to do is to calculate the volume of the bigger cone, which is the one that has a height of 8 cm and a radius of a height of 16 cm and a radius of 8 cm, minus the volume of the smaller cone, which is the one that has the height of 8 cm and the radius of 4 cm. When we do that, then we can be able to subtract them, and what we're left with is the volume of the frustum. Without taking these steps, we cannot really calculate the volume of the frustum, because your frustum has an incomplete information. All right, it has an incomplete information. You just have a diagram like this, but you don't have the total length of the height, the value of the height. You don't have that. All right, so we need to take these steps in order for us to be able to calculate the volume of any given frustum. So let's go ahead and do this. Therefore, the volume of the frustum is given by the volume of the bigger one. We can call it V1 minus V2. Now, remember that our volume is given by 1 over 3 pi r squared h. All right, so going ahead to put the values for the bigger cone, we are having that's for the big cone. We can call that, let's say, BC. That's the big cone. The volume is equal to 1 over 3 times our pi, that's 22 over 7, times the radius of the big cone, of course, that is this radius here, which is 8 cm. Okay, so the radius now is 8 cm times, but not just 8 cm, but it is 8 squared. Okay, times the height. The height is this one, the height of the bigger cone, and that is 16. Okay, that's 16. Whereas for the smaller cone, let's call that SC. That's a small cone. The small cone, the volume is still the same formula, 1 over 3 pi r squared h. So we are having 1 over 3 times the pi remains unchanged as a constant, 22 over 7, times our r now, that is the radius for the small cone. When you consider the smaller cone, that is this one here, let me try to identify that. The radius of it is 4 cm. All right, so we are having r squared, not just 4 but 4 squared, and times the h, which is the height, and the height of it is, that is from here to here, is giving us 8 cm, just like we have by the side. So we have 8. Now, making use of the calculator to simplify all this, 1 over 3 times 22 over 7 times 8 squared, that's 64, times 16, all together, that will give us, therefore, the BC, that is the big cone. The big cone will simplify 1 over 3 times 22 over 7 times 8 squared, that's 64, times 16. When you punch that into your calculator all together, that will evaluate to approximately 1072.7 cm. All right, and for the smaller cone, which we have selected the SC, when we also punch that in the calculator, 1 over 3 times and 2 over 7 times 4 squared, that's 16, times 8, that will evaluate to 134.1 cm approximately. Therefore, the volume of the frustum, okay, is given by the volume of BC, that's the bigger cone, minus volume of the smaller cone, that's SC. And from what we have here, from the foregoing, we already have that to be 1072.7 minus 134.1, and altogether that will give us, okay, so that will give us our volume to be 938.6 cm cube. Oh, I forgot to, when I was writing this, they are supposed to have cube. Remember that your volume has cubic units, so it's not just cm but cubic units. So we're having the volume of this, given the frustum under consideration here, will be 938 cm. And this is really how we calculate the volume of a frustum. However, this is not all that there is to it. In the next video, we will be looking at how to, because sometimes there are some manipulations that you need to make in order for you to get all these radius and height. For this particular example, all needed values were supplied. The radius 1, that is the R1 and the R2, respectively standing in for the radius of the smaller cone and the bigger cone. Then you're having the H1, H2, that is for the height of the small cone and height of the bigger cone. They are all given, so we don't really have any problem. But in some cases, they are not given. Alright, so we are going to look at in the next video how we can derive that using the concept of similar triangles. So I'll be seeing you in the next video. Alright, so please go through this and try to like look at what is possible. Alright, so try to do this like an assignment. Alright, so try to use this as an assignment to solidify what we've just looked at. So try to calculate the volume of this frustum. Calculate the volume of a frustum. Let me make the drawing. So we are having this frustum. Okay, we are having this complete cone wherein we have a frustum halfway, okay, such that the height of this cone, the height of the cone, that is the total cone, is giving us 10 cm. Alright, but when you consider the frustum, the height of the frustum, is giving us let's say 6 cm. Now there is a little bit of twist here. Alright, there's a little bit of twist here. I'm looking forward to you being able to see that, but anyway, let me just tell you that now for you to get the height of the cone, remember that you are going to do the height of the bigger cone minus the height of the frustum, and that will give you the height of the smaller cone. Don't forget that. Alright, then the radius of the big cone is 9 cm, and for the small cone the radius is 5 cm. So go ahead and try to solve this. Get me or solve for the volume of the frustum. If you're able to do this, then you, of course, you I'll be sure that you are ready for the next class. Alright, so watch this video as many times as possible, as much as you can. Try to pause wherever you can and understand what we are doing. I'll be seeing you in the next video. Until then, stay safe and bye.